In this episode, we will build a simple tooltip for our items that can be used universally, not just inside the inventory but anywhere we need it. Let's get started. First, navigate to the UI, Widgets, Inventory folder and add a new widget blueprint. Choose User Widget as the base class and name this file WP_slot item tooltip. This will be our dedicated tooltip widget for displaying item details. We begin by dragging a size box into the canvas and set its min desired width to 350. This makes sure that our tooltip window always has a minimum width, so text or content never appears too squeezed together. Next, add an overlay inside the size box. The overlay lets us stack multiple elements like borders or text layers on top of each other, which is perfect for building flexible layouts. Inside the overlay, add a border and rename it to background border. This border creates the visible outer frame of the tooltip window. Set its horizontal alignment and vertical alignment both to fill. This makes sure the border stretches to the full size of the overlay container. For the padding, set the content padding of the background border to 1. This will later create a thin line around the window, adding a subtle border effect. Now set the brush color to hex D1E2AB3 with an alpha of 0.7. This gives the outer frame a soft color tone and makes it slightly transparent so it doesn't feel too solid over the game world. Next, drag another border into the background border and rename it to background. This will be our actual background layer that holds the tooltip's main content. Set its brush color to black and increase the alpha to 0.9 for a darker, more readable background. Set the content padding here to 8. This creates enough inner spacing for text or icons so nothing sticks too close to the edges. Finally, at the top of the designer panel, change the fill screen option to desired on screen. This ensures that our tooltip always stays within the visible screen area and won't get cut off, no matter where the player's cursor is. If you zoom in, you'll see a nice clean frame around the window. This makes the tooltip stand out more clearly against any background. Next, search for a vertical box and drag it onto the overlay. The vertical box helps us stack multiple text elements neatly on top of each other, perfect for showing item details in a clean column. Set the padding for the vertical box to 6 and adjust both horizontal alignment and vertical alignment to fill. This ensures the entire box uses the available space inside the tooltip window and the padding keeps the content nicely spaced from the edges. Now search for a text element and drop it inside the vertical box. Select this text and set its padding to 5. Expand the padding settings and adjust the bottom padding to 10. This gives the item name extra space below so it does not stick too close to the next line. Set horizontal alignment and vertical alignment both to center to keep the text centered inside the tooltip. Change the displayed text to item name in brackets. This reminds us that this is just a placeholder that we will update dynamically later. For the color, set the brush to D1, E2, FF. This matches our main accent color so the item name stands out nicely. Change the font size to 16 to make sure it's large enough to read at a glance. Rename this text element to text_item name and check is variable to true. This means we can set or update the name dynamically from blueprint logic whenever we show the tooltip. Next, drag in another text element into the same vertical box. Select this one and rename it to text_stack size and again make sure is variable is true. Set its left padding to 15 and bottom padding to 3. This creates a bit more spacing on the left, so the stack size sits slightly indented under the item name and does not look too flat. Set its horizontal alignment to left so it sticks to the left edge of the column and vertical alignment to center so it stays aligned in the middle vertically. Change the placeholder text to stack size in brackets so it's clear this will later display the current stack count. Set its brush color again to D1, E2, FF to keep our tooltip color style consistent. Finally, set the font size to 12 and the typeface to regular to make this line slightly smaller than the item name, giving it a nice hierarchy. If you want to learn how to build a professional tooltip or inventory system with a fully modular design, check out my MSG course. Every widget is designed as a modular building block, like the dedicated text widget for numeric values, which can be assembled dynamically through settings in the Details panel. This makes them highly flexible and easy to adjust globally whenever needed. Throughout the entire course, which now includes more than 120 lectures, all blueprints are structured and clearly organized. Each step is explained in detail so you always understand what you are building and can follow along without confusion. The file structure is clean and shows you how to keep your project organized from day one. The entire UI is modular and made up of custom-built widgets that are reused throughout the project. This makes it simple to manage changes globally with minimal effort. In the MSG course, you will learn how to build a complete game from scratch in a clear, step-by-step way with detailed explanations at every stage. For more information, visit msgcourse.com. English and German support is available for the entire course. Next, duplicate text stack size and rename it to text_weight. This new text element will display the weight information for the item. Set the bottom padding to 0 so it aligns neatly with the other elements below. Now duplicate text weight and rename it to text_description. Set the top and bottom padding to 8 to create enough spacing above and below, making sure the description stands out visually without feeling cramped. Change the color to light gray so the text appears more subtle and does not distract from the main item details. Update the displayed text to description as a placeholder and adjust the font size to 10 to match the less prominent style of a description line. Compile and save your work once and switch over to the graph. Remove the pre-construct and tick events since they are not needed here and only add unnecessary overhead. Add a new variable named item data asset of type PDA item data as a soft object reference. This will hold a reference to the item's data asset, giving you access to all its core details when needed. Make this variable instance editable and expose on spawn so you can assign it directly when creating the widget in other blueprints or UMG setups. Add the next variable named slot data of type inventory slot. This stores the data for the current slot, allowing you to display more specific details from the item in this particular slot if required. Again, set it to instance editable and expose on spawn for easy access when the widget is created. Finally, add a variable named item data of type PDA item data object reference. This will store the resolved item data at runtime. Mark it as private since it is only needed within this blueprint and does not have to be exposed externally. Always remember to compile and save your progress as you go to avoid losing work in case the editor crashes unexpectedly. Next, add a branch node right on construct. For the condition, drag slot data into the graph and call isSlot_not_empty on it, then connect that to the branch. This checks whether slot data was passed in or not. If it was not set, we initialize it once here. This makes sure that if you display the item somewhere outside of the inventory, where no slot data exists, you still have access to certain slot-specific details. While this is not the main focus of this lecture, it is included so you already have access to the slot information later if you need it. Call a setSlotData node on the false execution path of the branch. Drag item data asset into the graph and use makeItem to add, then set the quantity to 1. This creates a simulated slot that acts like it holds one item, so we always have at least basic slot info ready. Connect the result of this node to the setSlotData node to store the generated data. Now call an async load asset node on item data asset. This node loads the actual asset in the background without blocking the game thread. It is especially useful here because our item data asset is a soft object reference, so we avoid loading every single asset into memory upfront. Instead, we only load what we need, when we need it, which keeps the game lightweight and efficient. Connect both the true execution path of the branch and the execution output from setSlotData to the async load asset node. This ensures that no matter if we already have slot data or just created it on the fly, the item asset will always be loaded asynchronously right after. Next, call the getItemAsset message interface on the object output from the async load asset node. This gives us the fully resolved item data once the asset has finished loading. Make sure to reconnect the completed execution pin from the async load asset directly to the getItemAsset node. This guarantees that the getItemAsset call only runs after the asset is actually loaded, preventing errors or empty data. Write the result from getItemAsset into the item data variable so we store the resolved item details locally in this blueprint and can reuse them whenever needed. Then, drag text item name into the graph and call setText on it. Right after, drag item data in and call getItemName, then connect its output to the text pin. This sets the displayed name to match the resolved item name so it always shows the correct value. Next, drag text description into the graph and call setText. Call getDescription on item data and connect its output to the text pin too. This fills the description text with the relevant item description from the data asset. Now drag text stack size into the graph and call setText, then connect this node to the execution flow. For the text input, add a format text node. Format text lets us build strings dynamically by inserting variable values into a formatted string, which keeps the display flexible. In the format field, type max stack size and add brackets around value to create a named placeholder pin for the actual value. Call getStackSize on item data and connect its output to the value pin of the format text node. This inserts the real stack size into the placeholder when the text is generated, so the displayed value always matches the correct maximum stack size from the item data. Last, drag text weight into the graph and call setText on it, then connect it to the execution flow. For the text pin, add another format text node. In the format field, type weight value kg and place value in brackets to create the placeholder. Call getWeight on item data to get the item's weight and connect that to the value pin of the format text node. This way, the weight will be displayed in kilograms right next to the label, making it clear and readable. Here, if you want, you can read the weight directly from slot data instead and show the total weight when hovering over the item. This is exactly what we prepared for earlier. No matter if slot data is set or not, the tooltip will always display either the default weight or the total weight from the inventory slot, depending on what is available. Compile and save everything to make sure your work is secured, then switch back to the map view. Open the WB_item slot master widget because we want to integrate our new tooltip widget here. If you enjoyed the video so far, I would really appreciate it if you leave a like. And if you do not want to miss any future videos, I would be happy to see you subscribe to the channel. Select widget slot in the hierarchy and expand the advanced section inside the behavior section. Here you will find the tooltip widget property, which lets you define a custom widget that appears when you hover over this slot. Click on the small chain icon next to tooltip widget and select create binding. Unreal will automatically create a new function named getWidgetSlotTooltipWidget. Rename it immediately to get_tooltipWidget to keep your naming clean and clear. In this function, we will now set up our custom tooltip for this slot. Drag item data asset into the graph. Right-click on it and convert it to a validate get node. This node safely checks if item data asset is valid before using it, helping you avoid runtime errors when the asset is missing or not yet set. Call create widget on the isValid execution pin. This will only create the tooltip if the item data asset is valid, which keeps the logic clean and avoids unnecessary widget creation when there is no data available. For the owning player input, use the getOwningPlayer node. This node makes sure the widget knows which player owns it, which is required for proper UI rendering and input handling. As the widget class, select our WB_slot_item tooltip widget. This brings up the two variables we prepared earlier, so we can now pass in the data we want to show. Connect item data asset directly to the corresponding input pin on the widget so it knows which item's data to display. For slot data, use the slot data variable. This ensures the tooltip can access any slot-specific information if needed, giving you maximum flexibility for showing more detailed data later on. Finally, connect the execution pin from Create Widget to the return node, and do not forget to connect the return value from Create Widget to the return value pin of the function. This makes sure the newly created tooltip widget is properly returned and displayed by Unreal when you hover the slot. Compile and save everything to secure your changes and you are ready for a quick test. Start play mode, give yourself a few items and run over to the chest to open it. When you hover over an item now, you should see the simple tooltip appear. No matter where the item is displayed, the tooltip will always show up correctly. Unreal takes care of showing and hiding it automatically, so you do not have to handle that part yourself. That wraps up this episode. I hope you enjoyed it and see you in the next one.